2026 A-Level Chemistry Paper 1, questions 31 up to 40. If you are interested in the other questions from question 1 up to question 30 or question 41 to question 50, then check out the links in the description down below. Now in these questions from 31 up to 40, each question has 4 answers labeled A, B, C and D. And out of these, when you find which of them are correct, you can then go up and use this answer key to find the correct response number. Now if only the answers A and B are correct in your question, then you have to select response number 1. Similarly, if only B and C are correct and other 2 are wrong, you choose response number 2. If only C and D are correct, you choose response number 3. If only D and A are correct, you choose response number 4. And for any other combination of responses, let's say A only, or A and C, or B, C and D being correct, or any other combination like this, outside of these 4 combinations right here, you will choose answer number 5. Now according to that, if we start off with the first question, question 31, it says, which of the following statements are correct regarding the standard hydrogen electrode? Now looking at the first statement, it says the standard electrode potential value of the standard hydrogen electrode is considered as 0.00 volts. Now this statement is correct as the standard hydrogen electrode is the electrode with respect to which all other electrode potentials are measured. Due to that, if we consider measuring an SHE with respect to another SHE like this by putting a voltmeter between them, since both of these will have the same exact potential, the potential difference here is 0 and thus the standard potential of a SHE is 0.0 volts, making statement A correct. Now moving on to statement B, it says the half reaction is irreversible. Now the half reaction that occurs here is the interconversion between H plus and H2 gas in the presence of a platinum wire. Now this reaction is 100% reversible, and depending on the situation we can either have H plus converting into H2 or H2 converting into H plus. Now according to that, statement B, which says the half reaction is irreversible, is incorrect. Now moving on to statement C, it says the half reaction is always spontaneous. Now this is also incorrect, as considering these two half reactions, when the forward one is spontaneous, the reverse one is non-spontaneous and vice versa. So therefore, any of these will not always be spontaneous. It will be spontaneous sometimes and non-spontaneous in the other cases when the other reaction, the reverse reaction, is spontaneous. So therefore, statement C is also incorrect. Now moving on to statement D, it says it can act as the anode or the cathode depending on the electric metal cell that is under consideration. Now this statement is correct, as if you consider these two half reactions, when this one is spontaneous, we have H plus turned into H2 gas by absorbing electrons, and when you absorb electrons or gain electrons, it is considered as reduction, and reduction occurs at the cathode. So therefore, when this reaction occurs, we have a cathode in the case of standard hydrogen electrode, so it's occurring as a cathode. However, when this reaction is non-spontaneous and the reverse is spontaneous, we have H2 gas turning to H plus by losing electrons, and therefore we have loss of electrons, which is oxidation, and oxidation occurs at the anode. So therefore in that case, we have the SHE acting as an anode. So it can act as both the anode or the cathode depending on the situation. So statement D is also correct. Now according to that, since only A and D are correct, if you look at our answer key, we can see only A and D are correct corresponds to answer number 4. So the answer for question number 31 is answer number 4. Now moving on to question number 32, it says which of the following statements are correct regarding the reaction of acetone with 2,4-dinitrofenyl hydrazine, aka 2,4-DNP. Now looking at statement A, it says it is a two-step reaction where the second step is a dehydration reaction. Now to answer this question, I've actually brought in the actual mechanism of the reaction between a ketone and 2,4-dinitrofenyl hydrazine. Now looking at the mechanism, we can see there are 2 steps, and in the first step we have nucleophilic addition where the electrons of this nitrogen attack this carbon right here, resulting in this intermediate compound, which then in the second step undergoes dehydration by having this OH and this H break off as a H2O, and resulting in this compound right here where this carbon and this nitrogen create a double bond between them. So according to this, we can see we have two steps. So it's a two-step reaction, and also the second step is a dehydration reaction. So according to that, statement A is correct. Now moving on to statement B, it says the product formed in the first step of the reaction can be isolated. Now what they're talking about is this product right here. Now this product actually cannot be isolated as it will immediately dehydrate to create the final product over here. So due to that, statement B is actually incorrect. Now moving on to C, it says the structure of the colored product formed in this reaction is this compound right here. Now this is incorrect as the actual colored product formed here is this structure right here. We can see the nitrogen-nitrogen double bond is incorrect. It should instead be nitrogen-nitrogen single bond. There should be hydrogen and nitrogen, and also we should have a double bond here, and this OH should have gone with the hydrogen that was there on this nitrogen right here. So therefore this should be gone, and we should instead have this structure right here as the colored compound created. So therefore statement C is also wrong. Now moving on to statement D, it says this reaction can be used to distinguish acetone from acetic acid, and that statement is correct. It's correct because acetone, which is this compound right here, will react with 2,4-DNP to create this color compound right here. However, acetic acid, which is this compound right here, will not react with this compound to create this kind of colored product, and therefore if you put 2,4-DNP to both acetic acid and acetone, acetone will change color while acetic acid will not. So therefore statement D is correct. Now according to that, since only A and D are correct, we once again have answer number 4 as the correct answer for this question. Next, if you consider question 33, it says soap is a sodium or potassium salt of fatty acids. Given that they ask us identify the correct statement or statements regarding hard water and soap, where hard water is water with magnesium 2+, calcium 2+, or other polyvalent metal cations, but usually only magnesium 2+ or calcium 2+, as they are the two most common ones. Now considering that, statement A here says the cleaning efficiency of soap is higher in hard water than in pure water. Now this statement is 100% false, as in hard water, soap is almost ineffective. So due to that, statement A is false. Now moving on to statement B, it says precipitates formed by reacting polyvalent cations with soap are more dense than water. Now this first part is correct, however when it says more dense, it is incorrect, as the precipitates formed are less dense than water and will float on water as white clumps. So due to that, statement B is incorrect. Now moving on to statement C, it says a precipitate is formed by the attraction of anions of fatty acids to polyvalent cations, and this is a correct statement, and the precipitates that are formed here are the precipitates described in statement B. Now moving on to statement D, it says some of the polyvalent cations in hard water are calcium 2+, magnesium 2+, and iron 2+, and this statement is also correct. Now according to this, we can see only C and D are correct, and from only C and D we can see the correct answer is answer number 3. So the correct answer to question number 33 is answer number 3. Next, if we consider question 34, it says which of the following statements are true with regard to the chemistry of nitrogen. Now statement A says nitrogen is slightly soluble in water under normal atmospheric pressure, while the solubility of nitrogen in water increases with increasing pressure. Now this statement is correct, and in general, for any gas, when you increase the pressure of that gas, its solubility in liquid will increase. Now fun fact, this is actually the reason why when you take a soda bottle and open it, the gas suddenly escapes. It's because normally the pressure inside the soda bottle is higher than the standard atmospheric pressure. Due to that, you can actually dissolve more CO2 inside the liquid than you would be able to at atmospheric pressure. Due to this, when you open the bottle, you will be decreasing the pressure of the inside of the liquid, and due to that, the extra CO2 dissolved in the liquid will no longer be able to stay dissolved in the liquid and will thus fall out of the solution as gas bubbles. So anyway, moving on from that, statement B says nitrogen shows oxidation numbers from -3 all the way up to +5, and this statement is true. And in fact, here are a couple of examples of nitrogen compounds where nitrogen shows all of the oxidation numbers from -3 all the way up to +5. Now moving on from that, statement C says nitrogen has several allotropes. Now an allotrope is an elemental form of that element, and according to that, Since under normal atmospheric conditions, nitrogen only has one allotrope of N2 gas that we have in the atmosphere, we can say it has only one allotrope and not several allotropes. So therefore statement C is incorrect. Now moving on to statement D, it says atmospheric nitrogen is converted to ammonia during lightning. Now while nitrogen does react in the presence of lightning, it does not create ammonia. Instead, nitrogen will react with the oxygen in the atmosphere to create either NO or NO2. So due to that, statement D is also incorrect. So from this we can see statement A and B are correct only and statement C and D are both incorrect. And A and B only corresponds to answer number 1. So therefore, according to these statements, the correct answer here is answer number 1. Now moving on to question 35, it says, consider the following half reactions at 25 degrees Celsius. The first reaction is silver plus 1 electron to silver. The second one is copper 2 plus 2 electrons to copper. And the third one is zinc 2 plus 2 electrons to zinc. And for each of these, we have been given their standard reduction potentials of 0.8 volts, 0.34 volts, and for zinc, negative 0.76 volts. Now considering this, they ask us which of the following statements is correct. Now looking at statement A, it says, when a rod of zinc metal is placed in a copper sulfate solution, copper metal is deposited on the zinc rod. Now to answer this one, what we need to do is to consider this reaction and this reaction. Now in order for what they're talking about here to happen, we need to have zinc metal plus copper 2 plus reacting, and the zinc needs to give its electrons to copper, turning it into zinc 2 plus and copper metal. Now for this to happen, we can see we need this reaction to happen in the normal direction and this other reaction to happen in the reverse direction. Now if we consider the potential change there, we can see we need the positive value of this reaction, which is going to be plus 0.34, and we need the minus value of this reaction, which is minus negative 0.76, and adding them together we can see we get plus 0.34 plus 0.76, which is equal to plus 1.1. And since the potential of this reaction is positive, we can say this reaction will be a spontaneous reaction. So therefore, zinc rod turning copper 2 plus into copper and depositing it on the rod will be a spontaneous reaction and therefore will happen. So statement A is correct. Now moving on to statement B, it says, among the electrochemical cells that could be assembled, the cell zinc solid plus zinc 2 plus, or rather interface is zinc 2 plus, salt bridge with silver plus and silver solid has the highest EMF value. Now considering this, we can see this is the anode side and therefore we must have oxidation happening here, and this is the cathode side, so we must have reduction happening here. Now out of these reactions here we can see this direction is reduction, so therefore oxidation is this direction. Now considering that with this cell we would have potential of E being equal to the reduction side of plus 0.8 minus the oxidation side, which is again minus negative 0.76, which gives us a potential of plus 0.8 plus 0.76, which substitutes and simplifies down to 1.56 volts. Now according to that, since the potential of this one is positive and it's the largest potential difference among any of these, we can say that this reaction will happen in the positive direction, as in the forward directions of the cell is correct, and also it will have the highest potential difference among any of the cells created using these reactions. So therefore statement B is also correct. Now moving on to C, C says, when a rod of silver metal is placed on to a copper sulfate solution, copper will be deposited on the silver rod. Now concerning those two half reactions, we can see for silver in the forward direction we have plus 0.8, and for copper in the forward direction we have plus 0.34. Now what we need here is the reverse of silver, as in silver metal, or 2 silver metal rather, reacting with copper 2 plus to convert into 2 silver plus and copper solid. Now according to that, we need to have the reverse direction of this reaction and the forward direction of this reaction, and from that we can see the standard potential will be this forward direction potential of plus 0.34 minus this reaction of 0.8, which gives us a negative value of minus 0.46. Now, since the potential here is negative, this reaction in the forward direction will not be spontaneous. And therefore, saying it is spontaneous and therefore copper will deposit is incorrect. So, statement C is incorrect. Now, moving on to D, D says hydrogen gas is not liberated, keyword not, when copper is added to a solution of 0.1 molar of sulfuric acid. Now, here we need to know that the reaction in between H plus and H2 gas is the standard cell reaction of the standard hydrogen electrode, which is H plus to H2 gas, which has a potential of 0 volts, as we discussed in question number 31. Now, accordingly, we can see for this particular reaction, if the potential is 0 volts, and for this reaction, if the potential is 0.34 volts, and we want this reaction to occur in the forward direction, and this one to occur in the reverse direction, the potential there will be equal to 0 volts minus the reverse direction one, which is plus 0.34 volts, which gives us a potential of minus 0.34 volts. Now, due to that, we can see, since the potential in this one is negative, this reaction in the forward direction will not happen. Now, since the question said, or our statement said, it will not happen and therefore H2 gas will not be liberated, the statement is correct. So, therefore here, statement A, statement B, and statement D are all correct. Now, since this combination of A, D, B, and D is not included in the answer key there, we can say the answer here is answer number 5. The answer question number 35 is answer number 5. Now, moving on to question number 36, it says, which of the following compounds will not form a Grignard reagent as the final product when it is reacted with magnesium in dry ether? Now, for this question, we know that if you have a compound of the form Rx, where R here is a carbon chain and X is a halogen, and you react it with magnesium in dry ether, then you will create a compound of the form RMgX, which is what is known as a Grignard reagent. So therefore, in order to create a Grignard reagent, you have to have a compound of the form Rx, where R is a carbon chain and X is a halogen. Now, according to this, if we look at the compounds A, B, C, and D, we can see, while A, B, and D all have halogens as bromine here, chlorine here, and bromine here, C does not have a halogen. Therefore, if you react it with magnesium in dry ether, it will not be able to create a Grignard reagent. So therefore, C is immediately a correct answer, as we're looking for the ones that do not form a Grignard reagent as the final product when reacted with magnesium in dry ether. Now therefore, considering the other three of A, B, and D, each of these compounds should be able to at least temporarily create their own Grignard reagents. Now, according to this, we can see if we take A first, A will create a Grignard reagent CH3, C double bond O, CH2, CH2, and instead of Br, we'll have MgBr. Similarly for B, we'll have CH3, actually not CH2, it's just CH, NH2, CH2, CH2, and instead of chlorine here, we'll have MgCl. And finally for D, we'll have Br, Mg, CH2, CH, double bond CH2. So these compounds will at least temporarily be created upon reaction of these compounds with magnesium in dry ether. Now out of these three, only D's compound is actually stable, and therefore only D here will create a final product of a Grignard reagent when it is reacted with magnesium in dry ether. So therefore, only D is an incorrect answer, as we're looking for the ones that do not form Grignard reagents as final products when reacted with magnesium in dry ether. Now the other two, A and B, are actually correct. To understand why, we had to look at them separately, because A and B will both not be remaining as Grignard reagents for different reasons. Now if we first consider A will not remain, as if you consider a compound of the form R1, C double bond O, R2, and you react it with the Grignard reagent of the form, let's say R, MgBr, this compound will create a compound of the form R1, R2, R bonded to a single carbon with the oxygen here gaining an MgBr group on it. So it will be something like this. So due to this, if you have a carbonyl carbon and the RMGBr as in a Grignard reagent in present, they will react and create a compound like this. Now due to this, if you look at A, in the compound A itself, we have carbonyl carbon, and also in the Grignard reagent created, we have a carbonyl carbon. So therefore, the Grignard reagent created by A will react with both itself and also the original compound A, and therefore will not remain stably as this Grignard reagent. So A is incorrect and therefore will not form a Grignard reagent as the final product when react with magnesium in dry ether. Now similarly, if you consider B will not form this as a final product due to the fact that these hydrogens here will be attracted towards this carbon, which is going to be extremely negative charged, due to this magnesium, which is going to be positive charged. Due to that, when two of these molecules interact, one of the ammonia groups will give a hydrogen to this carbon and take the MgCl group onto itself. Due to that, this compound will create the compound CH3, CH, N, one hydrogen, and instead of the other hydrogen here, we'll have MgCl, and then we'll have CH2 and CH3, because this carbon right here will be negative and pull these hydrogens towards it. Due to that, we will not have this compound remaining as a Grignard reagent, so therefore it is also correct answer for this question. Due to that, A, B and C are all correct answers, and due to the correct answer here is answer number 5, since A, B and C all being correct is not an answer in our answer key. The answer to question number 36 is answer number 5. Now moving on to question 37, it says dichloro-difluoromethane aka R12 is used as a refrigerant in household refrigerators. Given that they ask us to identify the correct statement or statements. Statement A says the volatile compound R12 once released has a high potential to reach the stratosphere, and that statement is correct. R12 does not break down in the troposphere and can therefore float upward easily and reach the stratosphere. Now moving on to statement B, it says while R12 is stable in the troposphere, it decomposes to form chlorine radicals in the stratosphere, and that statement is also correct. R12 chemical formula CCl2F2 will easily float upward to the stratosphere where it will encounter ultraviolet radiation, and the UV rays will break the chlorine to carbon bonds homolytically, creating chlorine radicals. So therefore statement B is also correct. Now moving on to statement C, it says R12 is a greenhouse gas that contributes to global warming, and that statement is also correct. Now moving on to D, it says R12 depletes the ozone formed from photochemical smoke. Now while R12 does deplete ozone, it depletes ozone in the ozone layer that's there in the stratosphere. However, the photochemical smoke exists in the troposphere, and that ozone is not broken down by the chlorine radicals produced by R12. So therefore statement D is actually incorrect. Now from this we can see statements A, B and C are correct while D is incorrect, and that combination responses corresponds to answer number 5. So the answer to question number 37 is answer number 5. Next, if we consider question 38, it says at a given temperature, a rigid closed container having a volume of 1 decimeters cubed filled with a real gas has a lower pressure than the pressure calculated for the equal amount of an ideal gas. Now given this, they ask us which of the following statements does not or do not give valid reasons for the observed non-ideal behavior. Now looking at statement A, it says the volume of the real gas molecules cannot be neglected when compared to the volume of the container. Now to solve this one, let's consider the ideal gas equation PV equals nRT. Rearranging, we can see we get P equals nRT divided by V. So pressure equals number of moles times R times temperature divided by volume. Now similar to this equation, we can get an equation for a real gas where the particles' volumes are non-neglectable, and it will give us P times V minus NB equals nRT, where here N is the number of moles and B is a coefficient relating the number of moles to the volume of the particles in the gas. Now due to this, we can see if we rearrange this one, we can get P equals nRT divided by V minus NB, and here N and B are both positive numbers. Now considering these two situations, we can see since we use equal amounts of gas in both the real case and the ideal case, N here is equal in both of these expressions. Similarly, since they are both at a given temperature, T here is equal in both of them. Due to that, since R is a constant, nRT here and nRT here are both equal to each other. Now due to this, since V minus NB is a smaller number than V, nRT divided by V is a smaller number than nRT divided by V minus NB. So due to that, the pressure of the real gas that we assume here is going to be higher than the ideal gas that we assume based on this equation right here. Due to that, the real gas would have a higher pressure and not a lower pressure, which means that this one does not give a valid reason and is therefore a correct answer. Now moving on to statement B, it says velocity of the real gas molecules are lower than that of the ideal gas. Now this statement is directly wrong and is therefore correct answer because at the same temperature, both the real gas molecules and ideal gas molecules would have the same exact velocities. Due to that, the argument here is incorrect. Now moving on to statement C, it says because the molecules of the real gas are attracted to each other, they do not exert a force on the container walls which is equal to that exerted by the ideal gas. Now this statement actually gives a valid reason and is therefore incorrect. If the particles are attracted to each other as they fall outward of the gas like so, the gas particles in the center of the gas will pull on them harder, slowing them down and making sure they hit the walls of the container with less force than they would in an ideal gas. Now finally, if you consider statement D, it says the molecules of the real gas are attracted towards the walls of the container. Now this statement is not a valid reason, is therefore correct because if you had a container which is attracting the particles, they would actually accelerate when they fall towards the container. Due to that, they would hit the container harder than they would in ideal gas and therefore would exert more pressure, which means statement D is actually not giving a valid reason, is therefore incorrect. So due to that, the correct statements here are A, B and D, since each of them does not give a valid reason for why the pressure is lower in the real gas than the ideal gas. Now this combination of A, B and D corresponds to answer number 5 and therefore the question 38 has answer number 5. Now moving on to question 39, it says which of the following industrial processes utilize or utilizes the counter current principle? Looking at the first one, it says the production of sodium hydroxide by the membrane cell method, and that is not an example of the counter current principle being used. Moving on to the second one, B says the extraction of iron by the blast furnace, which is correct because if you consider what happens inside of the blast furnace, the solid particulates fall downward while the hot reducing gases rise upward. So they go in opposite directions, which is the counter current principle. Now moving on to C, C says the production of sulfuric acid by the contact process, which is also an example since when the sulfuric acid flows downward and the SO2 is rising upward, we have once again the counter current principle. Now finally, if you consider D, the production of ammonia by the Haber-Bosch process, in here we have only a gas-based reaction and therefore we actually don't have any counter current principle in there. So the correct answers here are B and C, and B and C only being correct corresponds to answer number 2. So for 39, the answer is answer number 2. Now finally, if you consider question 40, it says which of the following statements are true with regard to oxacids of sulfur? Looking at statement A, it says concentrated sulfuric acid can act as a dehydrating agent, which is true. Moving on to statement B, it says the reaction of SO2 gas with water produces sulfuric acid, which is actually false, as when you react SO2 with water directly, you will get H2SO3. However, if your water has some oxygen dissolved in it and you have enough time, through a process known as autooxidation, your H2SO3 will actually react with the oxygen and turn into H2SO4 or sulfuric acid. However, since this is a product that happens later and not the direct product of sulfurous acid, statement B is still false. Now moving on to statement C, it says hot concentrated sulfuric acid can react as an oxidizing agent with certain metals and non-metals, which is true. Now finally, if you consider statement D, it says sulfuric acid and sulfurous acid contain 2 SO double bonds each in their structures. Now while this is true for H2SO4 as it has the structure of HOS double bond O double bond O OH, it is not true for sulfurous acid as it has a structure of HO, S, double bond O, single bond OH, and a lone pair on the sulfur. Due to that, statement D is false. Now from this we can see only A and C are true, and therefore the correct answer here is answer number 5. And with that, we are done with all the questions from 31 up to 40. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.